Assalamualaikum. DM015 Mathematics. Topic 7. Matrices. Okay, what is a matrix? Okay, matrix is a rectangular array of numbers enclosed between brackets. So we can use normal bracket or maybe square bracket to represent a matrix. Okay, the general form of a matrix with m row and n column. Okay, as below. Okay, this is in a general form. We use the square bracket. Maybe you can also use normal bracket. Inside this matrix, so we have all the entries. Maybe only one entries or maybe many numbers of matrix. Starting by positions 1, 1 means first row, first column, and then ended by A, M, N, the last row and last column. Okay, for this matrix has M rows and N column. M and N is represent the order of this matrix. Okay, the order or dimensions of the matrix with M rows and N column is given by M by N. Okay, M by N. Okay, as you can see here. Okay, M by N means M numbers of row and N numbers of column. Okay, the matrix for which the entry is in ith row and j column is denoted by, okay, these are notations of matrix. We use the square bracket, or maybe we can also use the bracket, and A, I, J represent all the elements. Okay, let's see the types of the matrix. Okay, first we have the row matrix, only consists one row. Okay, one row here. Okay, this is in a general form, only one row and maybe so many columns here. Let's see the example for this kind of matrix. We have matrix A, row 1, 1, 2, 3, and matrix B only one row, and we have 1, 2, 3, 4, 5, 6, 7, 7 columns. Okay, next, second we have column matrix. Column matrix consists only one column. Okay, so the example that we have, okay, this is the general form of the column matrix, and a specific as an example, we have matrix of A, only one column, so we have 4 rows. B, one column with 2 rows. Okay, next we have a third type of matrix. We have square matrix. Square matrix has same numbers of row and column. For example, 1 by 1, 2 by 2, 3 by 3, and so on. Okay, let's see the example for this kind of matrix. Okay, we have 2 by 2 matrix, matrix A, matrix B, we have 3 by 3 matrix. Okay, then 4, number 4, we have 0 matrix. Okay, 0 matrix is a matrix with entries, all the entries are 0. Okay, this is the share for 0 matrix. We use capital letter of O. Okay, example. Okay, we have 3 by 3 matrix. Then another example, we have 3 by 2 and 2 by 2. All the entries are 0. Okay, so okay, number 5, we have diagonal matrix. Okay, diagonal matrix is a square matrix which non-diagonal entries are all 0. Okay, the diagonal. So before that, you have to know which part is the diagonal. Okay, let's see the general form of matrix. The diagonal entries are the entries with the same numbers of row and column. For example, this one A11, the same numbers, A22, A33, and so on. Okay, this is the diagonal entries. Okay, so let's see the example for this diagonal matrix. Okay, first example A, we have 2 0 0 3, non-diagonal. Okay, this is the diagonal. Okay, non-diagonals are 0. The second, okay, matrix B, this is the diagonal. Okay, non-diagonals are 0, same as C. This is the diagonal entries. Okay, the others must 0. So the diagonal can be any numbers. Okay, next we have number 6, identity matrix. Identity matrix is a diagonal matrix where all its diagonal entries are 1 and denoted by capital letter of I. Okay, this matrix has only 2 entries, 0 and 1. 0 for the non-diagonal entries and 1 for the diagonal entries. Okay, this one for 2 by 2 identity, 3 by 3 identity. So as you can see, we have only 2 numbers. The diagonal entries 1 and the others, the rest is 0. Then 7, lower triangular matrix. It is a square matrix and the element of A, I, J must be 0 for conditions I is less than J. I is the row, J is the column. Okay, so less than, so this is the one. 1 2 1 3 3 2 3, sorry. So this is I less than J, so this is the lower diagonal. This 1 2 3 must be 0. Okay, example. Okay, number 8, we have upper triangular matrix. Okay, contra with the lower. So the lower part must be 0 for the entries I bigger than J. Location for the positions here, 2 1, 3 1, and 3 2. All of these must be 0. Okay, the example. Next example that we have. Okay, that's all for the types of the matrix. Okay, operations on matrices. Additions and subtractions of matrices. Let's say we have 2 matrices A and B. The addition and subtraction will give a new matrix. For example, C and D. To perform these operations, first, the order of the matrix must be the same order. Okay, so in order to get the new matrix, the operations must be between element or entries with the same positions. Here, for example, here Cij is the subtractions or additions between position Ij for the A matrix and positions Ij from the B matrix. Okay, this is the rules. To add or subtract two matrices, so you have to add or subtract the numbers in the matching position. For example, so if you have to find the entries of C11, so you have to add A11 plus B11. With some notification here, you have to take note about this. The additions or subtractions of two matrices with different orders cannot be performed, so it is not defined. And we say that the two matrices are incompatible. So to perform the addition or subtraction matrix must be between two matrices with the same order. Okay, let's see the example. First example 1. Okay, this is the version for addition. We have the first matrix, let's say A, and then we have the second matrix, let's say B. Okay, in order to get 1 1 position 1 1, so you have to add same position from the first matrix with the same position from the second matrix. For example, you have 3 plus 4 equals to 7, so same as the rest position. So 1 2 here, 8 plus 0 equals to 8. So these are the calculations as you can see in this table. Okay, example 2, the subtractions. Okay, same as additions, must be with the same position or matching position. A11 here 3, B11 here 4. We make subtractions, so we get -1, same as the others entries. So this is the calculation in this table. So we get this is the answer for example 2. Okay, next example 3. A, we have 3 different matrices, A, B and C. A 2 by 2 matrix, B also 2 by 2 matrix, and C is 2 by 1 matrix. So you have to find the summation between A plus B, B A minus B, and C A plus C. Okay, so the first question, you have to find the summations between A and B. Okay, so as before, this one position 1 1, we have to add with the same position from the second matrix. Okay, these two. Okay, so we have 5. Okay, 1 plus 4. Okay, then for this one, second entries, we have 2 1. Okay, we have 2 here. Position 1 2. 1 2. First row, second column, you have to add between these two. Okay, 2 plus 3. And for the second row, okay, second row, we have 3 positions to 1 for the first matrix, and we have -5 for the second matrix. So you have to add these two numbers. So we have somewhere here -2. And for the last entries, okay, we have 4 and 6. So we have, this is the one. Okay, the separation between the two matrices A and B, so same as before, must be the same positions. Okay, position 1 with position 1 1 from the second matrix, so you have to subtract these two matrices. Okay, so same as with the others, must be the shape and 3's. Okay, so we have 2, we have to subtract with 3. Okay, then we have 3 and negative 5. Okay, so 3 and negative 5, positions 2 1, you have to subtract, and the last one 4 and 6, so we can get this is the answer. Okay, well, for the third questions, A and C cannot be performed. This operation cannot be performed due to we have different order. A is 2 by 2 matrix and C is 2 by 1. Different order means that the operation is incompatible. Okay, we cannot perform these operations. Okay, next we have another operations, multiplication with a scalar. Let's see, it's a scalar, and then we have matrix A, so the operations of multiplication between that two object, matrix and scalar, will be give this new matrix, for example B matrix, but the operations must be as that one. You have to multiply all the entries in that matrix with the scalar. Okay, let's say this the first example for this operations. 2 times matrix of 4 0 1 negative 9, so you have to multiply all these entries with 2. So 2 times 4 we have 8, and then 2 times 0, 2 times 1, and 2 times negative 8, sorry, negative 9. So we'll get 8 0 2 and negative 18. Okay, next example 5. Okay, so you have to find the operations negative 1 over 2 times A, means that all these entries in A we have to multiply with negative 1 over 2. Each element must be multiplied with the given scalar. Okay, A multiply with negative 1 over 2, so all the entries also need to multiply with negative 1 over 2. So we have this is the answer. Next we have example 6. Let A given that matrix, and B we have 3 6 4 2. You have to calculate 3A times minus 2B. Okay, before we can perform the subtraction operations, we need to multiply with scalar first. Okay, due to the priority of multiplications is higher than subtractions, so you have to do it that one first. Okay, all the entries A must multiply with 3, and okay, entries of B, okay, this one you have to multiply with 2. All of these multiply with 2. Okay, this one also as this one, and the last one also multiply by 2, so you have 6 12 8 and 4. Then you have to subtract one by one with the matching positions. 3 minus 6, 12 minus 12, 15 minus 8, and 9 minus 4. Okay, so you have this is the answer. Okay, this is the size. You can try it on your own. Okay, that's all for 7.1. Part of them.